In previous class, what I discussed was the discrete systems. And now I will discuss continuous systems, okay? And the partition function will be again given by this Z1 is equal to 1 upon H integral e to the power minus beta H and dp dq. This will be the partition function. And H is Hamiltonian given by sum of kinetic energy and plus potential energy. Okay?
सर
Yes?
सर बोर्ड काफी शाइन कर रहा है सर बोर्ड क्लियर नहीं दिख रहा नो इट्स ओके सर
Okay. एक second. Is that okay?
यस सर
So this is the Hamiltonian. The Hamiltonian will comprise of kinetic energy plus potential energy. And this is the partition function. And please understand, this is 3-dimensional. So total 6-dimensional space. So this integral I have written only 1 times. But actually, suppose I write it for 1 dimension. 1 dimension. So Z1 will be 1 by H integral e to the power minus beta H and dpx and dx. So this will be 1 dimensional, and obviously it will be a double integral because integral is with respect to momentum and also with respect to position. Got it? This is how it goes. So just see how the 1 dimension is written, and you will understand that I have put only 1 integral here, but actually it is 6 integrals. 3 corresponding to P, but 3 corresponding to Q. So जानबूझ के मैं सिर्फ एक डालता हूँ नोटेशन में, so that you don't feel scary. Okay, we will manage because dp dq is there. That means it has to be integrated with respect to P also, and it has to be integrated with respect to X also. समझ आया? 1 dimension समझ लो, बाकी सब अपने आप हो जाएगा. Or if you want to show the 3 dimension, you can sometimes write like this also, d3p d3q, just to show that it will be dpx dpy dpz dx dy dz, but I prefer writing it like this. समझ आ रहा है भाई? ये देखो 1D वाला समझ आ रहा है सबको? So please see, and sometimes just to remind, I write it like this, dpx dx by h. So just to correlate with the summation, what you had, summation r and gr e to the power minus beta er, right? So this is number of quantum states, dpx dx by h corresponding to gr, and this is e to the power minus beta h corresponding to e to the power minus beta er. तो यहाँ से भी by analogy also you can write. Using the analogy also you can write how it becomes this. ठीक है? So today I will focus on the systems having partition function like this, having continuous partition functions. So we will discuss some systems having partition function like this. So let us try. एक बार ट्राई करते हैं. तो जैसे कि मान लो you have one dimensional system and it is a classical gas, for example, okay, and it is in a box and length 0 to L. So only one dimension is there, 0 to L, and it will have momentum, one dimensional momentum, and momentum will have obviously limit minus infinity to plus infinity, because some molecules will be moving towards the right, some will be moving towards the left, and there will be all type of molecules having velocities and momentum from minus infinity to plus infinity. And it is given that they are weakly interacting. Weakly interacting. Weakly interacting means the potential energy will not be considered. Okay. So we have to write for such a system, we have to write the partition function, the Helmholtz free energy, the internal energy, the specific heat, everything we can write. So it is a classical gas, one-dimensional gas. Only one dimension is available. Let us try with this simple problem. So the first step is to write the Hamiltonian. It will be given by px square by 2m and plus 0. Because it is a weakly interacting system, so the potential energy, that means the interaction energy, will be equal to 0. So partition function will be z1 is equal to integral 1 by h integral e to the power minus beta px square by 2m, and potential energy is 0, and dpx dx. So it will be a double integral. For momentum, it is minus infinity to plus infinity, and for x, it is 0 to L. देखो ध्यान से. So you should remember this integration minus infinity to plus infinity e to the power minus alpha x square dx is equal to under root of pi by alpha. So this will become 1 by h, and 0 to L dx will be integrated separately. It will become L by h, and this one px square by 2m will be integrated using this formula. It will become under root of 2 pi m kbt. 2 pi m kbt, where beta is 1 by kbt.
वो इंटीग्रल बोर्ड के बाहर जा रहा है.
ठीक है. कोई डाउट होगा तो आराम से पूछ लेना। ये है पार्टीशन फंक्शन। नाउ दिस इज ओवर। व्हाट इज एफ?
माइनस केबीटी लॉग जेड
माइनस केबीटी ln ऑफ z1 n पार्टिकल के लिए n टाइम्स कर देना। ओके, व्हाट इज u?
डेल
-1/z1
1 by del z by del
del beta. This is equal to -1 by L by h under root 2 pi m kbt. Yes, और del z by del beta half 2 pi m kbt to the power -1/2. और यहाँ पे मुझे उसके रेस्पेक्ट में डेरिवेटिव करना चाहिए, तो मैं क्या करूं? kbt स्क्वायर से मल्टीप्लाई कर लेता हूँ, राइट?
फॉर सीवी ना
फॉर यू भाई, डेल बाई
यस
डेल
सर
बीटा क्या होता है? बीटा इज 1/kbt।
यस सर
तो डेल बीटा बाई डेल टी इज -1/kbt स्क्वायर। तो डेल बीटा की जगह क्या लिख सकते हैं? -1/kbt स्क्वायर इंटू डेल टी। तो जब ये यहाँ पुट करोगे तो -kbt इट विल बिकम प्लस ना, माइनस माइनस प्लस हो जाएगा kbt स्क्वायर। तो अभी t के रेस्पेक्ट में ही करना पड़ेगा, तो ये हो जाएगा √2 पाई m kbt। दिस is very important. We can do it with respect to beta also. Okay, so u क्या हो जाएगा? kbt स्क्वायर अपॉन, ये नीचे आ जाएगा,
h by l।
और यहाँ पे डेल z बाई डेल बीटा हुआ था, तो l बाई h यहाँ भी था ना? यस और नो? डेल z बाई डेल बीटा था ना? तो एक तो ये कैंसिल हो गया, यहाँ पे kbt स्क्वायर आ जाएगा, यहाँ आ जाएगा 2 पाई m kbt, और यहाँ 2 पाई m kb। सो 2 पाई m kb और t
एक 1/2 भी है।
और हाफ
हाफ एक और है ना, हाफ। सो फाइनली u विल बिकम हाफ kbt, जो कि ऑब्वियस था। फ्री गैस है, आइडियल गैस है, और वन डायमेंशन है, सो एनर्जी शुड बी हाफ kbt। तो u के दोनों फॉर्मूले याद रखना है. One of this is this, another one is kbt square 1 by z del z by del t. Okay. For n particles, u will be equal to n into half kbt. And if you want to get cv, it will be derivative of this, and n will become na. So it will become how much? Half of r. This will be cv. And what is r? R is na, Avogadro number, into kb, Boltzmann constant. Please see this. एक बार देखो किसी को कोई डाउट है किसी स्टेप पे. There is a very simple system जिसके आंसर्स हमें पहले से पता थे. एनर्जी तो पहले से पता थी that it is going to be half kbt. But एक बार आपने पार्टीशन फंक्शन मेथड से देखा करके कि how it goes. Tell me भाई. Okay. Is that okay? आवाज नहीं आ रही क्या?
Yes, sir.
Yes, sir.
Yes, sir. Okay.
और एक और चीज बता दूं कि जैसे इफ यू रिमेम्बर जब हमारे पास वहां z होता था, इट वाज समेशन r gr e to the power minus beta er. ये होता था z in discrete
Yes,
system, and the probability for any energy level er was, remember, it was some gr
my
e to the power minus beta er upon
Z.
summation r gr e to the power minus beta er. यही होता था. It was like this. Hmm? So
Yes, sir.
similarly, in the case of continuous systems, like if z is 1 by h integral e to the power minus beta eh dp dq, it is like this. The partition function is like this.
Yes, sir.
So the probability, if you want to write, suppose, or you want to calculate any average value, suppose you want to get the probability. So probability you can manage it with length. Length is dq. So suppose 1D I am writing, so I will write dpx into dx. Okay. So suppose you want to get some probability in any length, so you will put limits like that. Probability, suppose you want from 0 to some L by 2. So you will put it like this. 1 by h integral minus infinity to plus infinity is for momentum. 0 to L by 2 is for length. Suppose you want to know the probability between length, and you will write here e to the power minus beta h dpx and dx, and over the total one, integral minus infinity to plus infinity 0 to L by 2 e to the power minus beta h dpx and dx. It will go like this. So suppose in the previous question, I want to know that what is the probability out of 0 to L, the particle is between, tell me,
सर डिनोमिनेटर में 0 से L नहीं होना चाहिए, टोटल ले रहे हैं तो
0 to L. Here it will be 0 to L total. Here it will be between 0 to L by 2. So if you want, अगर आपको probability चाहिए 0 से L total है और आपको चाहिए कि 0 से L by 2 के बीच में पार्टिकल है, इस बात की क्या प्रोबेबिलिटी है? ओके
यस सर।
समझ आ रहा है?
यस सर।
तो ये
प्रोबेबिलिटी फॉर द मोमेंटम स्टेट भी हो सकती है, किसी मोमेंटम में होने के लिए प्रोबेबिलिटी क्या होगी किसी
तो
पर्टिकुलर मोमेंटम के लिए?
उसके लिए मतलब हम एवरेज एनर्जी निकाल सकते हैं, एवरेज वेलोसिटी, एवरेज ऑफ दैट वी कैन कैलकुलेट।
ओके सर।
हम्म सो यू कैन कैलकुलेट दैट आल्सो कि इस वेलोसिटी से इस वेलोसिटी के बीच में होने की क्या प्रोबेबिलिटी है। ओके, अब प्लीज सी केयरफुली, ये सारे इंटीग्रल्स तो सेम ही है, ऊपर नीचे कोई फर्क नहीं पड़ेगा, ओनली dx इज डिफरेंट। सो ऊपर आएगा L/2 और नीचे आएगा L, तो आंसर हो जाएगा हाफ। ये बात देखना जरा ध्यान से और बताना अगर समझ आया है या नहीं आया। हम्म आर यू गेटिंग दिस?
यस सर।
Because whatever integral you will calculate by integrating this is present here also. So finally that will be cancelled, इसलिए no need to calculate that. Correct?
यस सर।
और अगर देखो ध्यान से इसी क्वेश्चन में, अगर तुम्हें मान लो कोई कहे कि एवरेज ऑफ एक्स निकालो, तो जैसे उसमें कर देते थे ना समेशन पी आर एक्स आर, वैसे ही यहां पे एक्स पुट कर देंगे और नीचे ऐसे ही रहने देंगे, दिस विल गिव द एवरेज। अब देखो जरा ध्यान से, ये बड़ा ही क्रिटिकल है, इज वेरी इंपॉर्टेंट। हम्म
सर ऊपर लिमिट 0 to L होगा ना?
नाउ I am calculating the average value, not the probability between 0 to L/2. Average of x. So please see, x will enter here. Huh? So now what will happen? This will be still for that gas where potential is 0. This will be still not creating any problem, but x will have to be integrated. So कितना आ जाएगा? ऊपर आ जाएगा L² by 2 और नीचे L.
L.
So it will be L/2. So average position of the particle will be at L/2, obviously. Average position. of the particle. ये अच्छे से समझ लो जरा. समझ आया? Average position of the particle.
यस सर।
और यहीं पे अगर मैं कर दूं कि व्हाट इज, देखो आपको क्वेश्चन बार बार बदल बदल के लिखना है. आई एम डूइंग इन द सेम वन ना. सपोज आई वांट एवरेज काइनेटिक एनर्जी. एवरेज काइनेटिक एनर्जी. Suppose I want this. Then what will happen? We will put here average kinetic energy, right? Px square by 2m. So what will happen? This time you can't cut that. This time dx will be gone, right? Dx wala same hoga. So only integral left out will be this 1 by 2m integral minus infinity to plus infinity px square e to the power minus beta px square by 2m and dpx by, what is this? Under root 2 pi m kbt. देखो समझ आ रहा है?
यस सर।
नो सर।
ये तो फिर से सेम. पहले बताओ L वाला कट रहा है वो समझ आ रहा है?
हाँ सर, वो उसी पार्ट पे डाउट है
क्या डाउट है बताओ?
सर। जैसे कि हमने यहाँ एवरेज काइनेटिक एनर्जी निकाला तो हमने जस्ट वहाँ सब्स्टिट्यूट कर दिया।
हम्म. तो यहाँ पे जिसका भी एवरेज निकालना है वो तो अंदर आएगा ना.
यस सर।
जैसे एवरेज XR होता था डिस्क्रीट वाले में, तो क्या लिखते थे? समेशन R PR XR. प्रोबेबिलिटी के साथ वो मल्टीप्लाई होता था, तो ऐसे दिस इज द टोटल टर्म ऑफ प्रोबेबिलिटी, सो इट विल बी मल्टीप्लाइड विद दैट. व्हाट इज डाउट?
अब क्लियर है सर। वो एक्सप्रेशन के साथ कंपेयर कर ले तो समझ आ गया।
तो ये जो 0 to L dx और 0 to L dx ये तो सेम ही आएगा जो भी आएगा. और यहाँ पे जब h की वैल्यू रखोगे, h इज व्हाट? px square by 2m. So when you will put this value, तो यहाँ पे उसकी वैल्यू से जब इंटीग्रेट करोगे तो यू विल गेट अंडर रूट 2 पाई m kbt. पहले भी आ चुका है. ये वाला इंटीग्रेशन करना है. व्हाट इज दिस? इंटीग्रेशन माइनस इन्फिनिटी टू प्लस इन्फिनिटी x to the power n. So we know formula like this, na? 0 to infinity x to the power n e to the power minus alpha x square dx. What is this?
वन
Half
बाय अल्फा टू द पावर
gamma n plus 1 by 2 by alpha n plus 1 by 2. This is the formula. So this will become क्या बन जाएगा? So this will become, बोलो भाई, what it will become? 1 by 2m and
half
this half
KBT
gamma 2 plus 1 by 2 by alpha, which is beta by 2m. Alpha and 3 by 2. And this is equal to ये हो जाएगा
√2 pi m KBT.
and in division this is what 3 by 2 है
1 2
half under root pi. So this will be 1 by 2m into half under root pi into what is coming from here 2 times 2m kbt to the power 3 by 2 minus 1 by 2. And this root pi and root pi will cancel. ये सारा एडजस्ट हो गया ना? तो यहाँ पे क्या हो जाएगा 1 2m से 2m कट गया हाफ मैंने एक्स्ट्रा लिख दिया है क्या
Sir, when you are converting the integration from minus infinity to infinity, then 0 to infinity, you miss the 2.
हाँ right. So I use this na minus infinity to plus infinity was there. So 1
Yes,
2
I
will be also there, right? 1 2 will be there. So this will become half kbt as expected. Half kbt. अब check करो. So obviously only kinetic energy is present. That should be equal to internal energy. That should be equal to internal energy. So, but the method to calculate the averages is clear. How to put it and how to calculate the average. Only integrations will pain you, but only for 2 or 3 questions. Then you will become comfortable. सबको क्लियर है? कोई डाउट है तो बताओ. If there is any doubt. Okay. Now, till this question, there was no potential energy. So it was just behaving like an ideal gas. And the results were well known. But let us introduce now the question in which, please write, the system has got the potential energy now. Vx is equal to some u naught x. This is the potential energy where u naught is some constant. And the value of this potential only exists for x greater than 0. And otherwise, the potential is infinity. Otherwise, the potential is infinite. Find the average value. Find the average value of x at equilibrium temperature, capital T. This is the question. So how to handle it? It is a one-dimensional system and you want average of x. So how to write it? देखो जरा ध्यान से कैसे लिखें average of x को 1 by h double integral e to the power minus
px square by
beta
m plus
px square by 2m plus u naught x. This is the situation. And dpx dx and you have to calculate average of x. So put x here, put the limits of momentum as this and limit of x as 0 to infinity, because from minus infinity to 0 x will become infinity, v will become infinity, and that will make the total term equal to 0. And upon 1 by h integral minus infinity to plus infinity integral 0 to infinity e to the power minus beta px square by 2m plus u naught x and dpx and dx. देखो ध्यान से. This is the average value. So this case, our Hamiltonian became what? Px square by 2m plus u naught x for x greater than 0. This was the potential. यहाँ तक क्लियर है सबको?
Yes, sir.
तो अब अगर ध्यान से देखो तो नेक्स्ट स्टेप में you don't need to calculate the momentum integration. Huh? So what will be
Yes.
the average x? It will be only 0 to infinity and e to the power minus beta u naught x into x upon 0 to infinity e to the power minus beta u naught x dx. देखो जरा इसके इक्वल हो जाएगा.
Yes.
It will become like this.
Yes, sir.
And this will become first function integration of second minus derivative of first integration of this and upon limit 0 to infinity 0 to infinity upon e to the power minus beta u naught x upon minus beta u naught limit 0 to infinity. पहले वाले टर्म में अपर लिमिट भी 0 और लोअर लिमिट भी 0. दूसरे वाले में कितना आएगा 1 अपॉन बीटा स्क्वायर u naught स्क्वायर अपॉन 1 अपॉन बीटा u naught beta beta u naught. So what will be the answer? kbt by u naught is the average value of x. देख लो जरा. मैंने ये यूज कर लिया कि इंटीग्रल uv, अदरवाइज आप डायरेक्ट भी फॉर्मूला यूज कर सकते हो. देखो समझ आ रहा है. समझ आ रहा है.
Yes, sir.
Yes.
Yes, sir.
Without and if so, this is how it goes. We got the average value of x. We can calculate the value of u also, the value of partition function, everything. Partition function you can write now for this system. I directly wrote this average value. Sorry. What was the partition function? You can write it now.
Yes, sir.
This was.
Yes, sir.
So for the same question, calculate the partition function U and CV as homework. Do this. Okay. अच्छे से समझो और कोई डाउट है तो पूछो. एक बार में क्लैरिटी आ जाती है. बस इंटीग्रल्स को थोड़ा सा आपको देखना होगा. उसमें भी कोई डाउट है तो पूछते चलो. ओके. Okay, let us again join in 5 minutes. Okay. Thank you.
Okay, sir.